Hello everyone, this is Dr. Tulika Malviya. I'm working as an assistant professor in the Department of Chemistry, University of Allahabad. And today I have made the small video on the concept of heterocyclic compounds. So what are heterocyclic compounds? These are relatively stable ring compounds in which one or more of the ring atoms are of elements other than carbon, which is called as heteroatom. Now, the word hetero means different. So, the heteroatoms which are involved other than carbon are mostly nitrogen, oxygen and sulfur. So, since these are the main atoms which are involved, so if we have a look on the oxygen heterocyclics, so here few of the examples I have illustrated. So furan and pyran are the two examples of oxygen heterocyclics in which you can see the oxygen replaces the carbon and hydrogen. And so furan is a 5-membered ring, and while pyran is a 6-membered heterocyclic ring. In nitrogen heterocyclics, pyrrole is the 5-membered heterocyclic compounds, while pyridine and piperidine are the 6-membered rings. In sulfur heterocyclics, thiophene, which is 5-membered, while thiopyran, which is 6-membered. So, if you can see, the benzene is a 6-membered cyclic aromatic compound. And if we replace one carbon and one hydrogen from the benzene ring with one atom of pyridine, then with one atom of nitrogen, we get pyridine. If we replace two carbons and hydrogens with one atom of nitrogen and hydrogen, then we get pyrrole. If two carbons and two hydrogens of benzene are replaced with one atom of oxygen, then we get furan. And if two carbons and hydrogens are replaced with one atom of sulfur, then we get thiophene. If we take a look on the order of reactivity, then pyrrole is the most reactive, which is greater than furan. Furan is greater than thiophene, greater than benzene. So benzene is the least reactive, while pyrrole is the most reactive compound. And on the contrary, if the order of aromaticity is observed, then you can see that benzene is the most aromatic, followed by pyridine, then pyrrole, then furan, then thiophene. Now, benzene is the aromatic compound. It has sp2 and sp hybridized carbon, and they follow the 6 pi electron Huckel rule, and so they are aromatic in nature. If you see the structure of pyridine, so in pyridine the delocalization of electrons are already done, aromatic in nature, and the two lone pair of electrons of nitrogen, they are not involved in the delocalization or aromaticity. So here pyridine very easily gives away its electrons, reacts with another elements, while in case of pyrrole, the lone pair of nitrogens, in case of pyrrole, they are involved in the aromaticity. So these electrons are not available for sharing or for any reaction, and so this pyrrole is less reactive, less aromatic, followed by if oxygen, among oxygen, nitrogen and sulfur, oxygen is the most electronegative element. It will not lose its electron, and those two electrons are involved in the aromaticity, so it will not lose its electrons and become anti-aromatic. It will not prefer to become an anti-aromatic compound. So the aromaticity will retain, and a lone pair of electrons of oxygen are not available for reaction, and so is the case of thiophene. That is why the aromaticity, furan has less aromaticity than pyrrole. Thank you.